Hello everyone, today we're going to look at usaco-training ski course design. In this problem we're given n hills which each have like an elevation, and then n is in the range from 1 to 1,000, as you can see. Okay, so for this example we're given 5 hills, which the first one has elevation 20, the second one has elevation 4, and then so on. Okay, so we're supposed to alter the elevation of the hills so that the difference between the maximum and the minimum hill is at most 17. As you can see here, at most 17. And then the cost to change the height of a hill, x units, costs x squared units. So for this example, these are the elevations. And then, as you can see, okay, so we want the minimum hill to be 4 and the maximum hill to be 21. So then all we need to do is alter 24 and 1, which then 4 minus 1, which is 3, you would square that, would be 9, and then the distance from 24 to 21 would also be 3, so that would be also 9, so then this would be 18, and this would be the minimum cost. Okay, so let's just put the elevation. So let's say we have 20, we have 4, we have 1, we have 24, and we also have 21. Okay. So notice that the maximum or the heights are in the range from 0 and then to 100. And this means that basically, let's just say in this case, the best solution would to be have the smallest height as in 4 and then the maximum as in 21. So notice that basically there's only 100 minus 17, which would be 83. So there's only like 83 choices. For example, for this case, we can try, let's just say we can try s equals 0 and then m equals 17. So in this case, to test this, we could just alter the items that are less than 0 to 0, and then the items that are above 17 to 17. So this would it would look like this. Okay, so for 20, the distance from 20 to 17 would be 3, so there would be 9, since 3 squared is 9. And then for 4, you don't do anything since it's already in between these. For 1, you also don't do anything. Okay, so for 24, your distance would be 24 minus 7, which would be 7, and then so this would be 49, and then we'll also add 4, so this would be 16. So as you can see, this is not the best solution. But then, let's just say our next one, we could also check for s equals 1, and then m equals 18. Okay, so you could also check that, and then you could see that this would actually be just another possible solution, but it's not the best solution. But then if you see the last thing to check would actually be s equals, or actually m equals 100, and then s equals 83. Okay. And then since there's basically only 0 to 83 for these start choices, we could actually just loop through all these 83 possible solutions, and then we just check for each of these elements. And then we just sum up the like temporary cost. And then all we need to do next is just to take the minimum of these costs. Because for these, because after s equals 1, you would do s equals 2, s equals 3, and finally you would do s equals 4, which would be the best solution. So basically, for the rest of the solutions, it would just be greater or equal to this, which you don't really want since you only want the minimum. So now for our algorithm, all we need to do is loop through from s equals 0 to s equals 83. We take the sum of the cost to change each element to either 0 or 17, or we either don't change it if it's already in between. Okay, and then we just take the minimum. So that's basically it. Okay, so this problem is called ski course design. So ski course design. Okay, so let's just include F stream. Okay. Okay, so we're given n elevation, so it will be int n. And then let's just call our elevations e. Okay, so the maximum elevation, the number of elevations would be 1,000, so that can be our max n. So we're reading from this problem is ski design.in. So upstream, and then you're writing to ski design.out. So let's read n, and then for each value of n, you're reading e of I. Oh, oops, e of I, typo. Okay, so now we need to loop through for our start. It would be from 0, and then it will be less than or equal to 83. Okay, so let's call this st for start. And then our n would be start plus 17. Okay, so now we need to basically sum the costs up. So let's call this our sum. Let's put it as long because it might be an overflow. I'm not sure. So now we need to loop through all the elements. Okay, so now we have a few cases. If it is less than the start, then you have to basically take the difference. Okay, so basically if e of I is less than start, then your sum, you would increment by, basically it would be the square. So let's actually define a square function. So we can just define sq of x times x. Okay. Of square e of I minus st. It actually should be st minus e of I. It doesn't really matter because since when you square it, it would just go from negative to positive. Okay, so now our other case is if it is above the maximum, then you would have to minimize it towards the maximum. So then if e of I is greater than the n, then you would get the square of e of I minus n. Okay, so now we actually should have an answer for computing the answer. And originally it should be just really big since you want the minimum answer. So now just to answer, actually just if the sum is less than the answer, now you need to update your answer since you want the minimum number or minimum cost. So now after this, you just need to print your answer. So for this, we have ski design.in. Okay, we actually don't need to create that. Let's put this up over there. Okay, so for this case, we're given this. Okay, so let's run this. Okay, let's check our ski.out. Okay, we're given 18, which is right. I'm just going to submit this to test. My ID is download3. This problem is ski design. And then the language, I'm using a C++11. Okay. So let's just select this file. Usaco-training. This is ski design. the course design. My bad. Okay. So it looks like that is our. If you have any questions, feel free to leave them in the comment section below. Bye.